Hello everyone, this is my video for my exercise 6, which will be the predictive modeling with regression. And I am on team 3, and my name is Nathan, and Sophie, Savannah, Freddie, and Mark are also in my group. So with that, we can go ahead and get started. So the first slide is 6-1, and it is a simple linear regression, and it's predicting the exam mark. And so there's a couple different things to point out here. And so on the left side, you can see the fit summary. And so the purple line or the purple bar is the hours revision. And then the blue bar is currently unlabeled. Let's see here. I believe that might be the one of these measurements at the bottom, a parameter estimate. So the top right is a residual plot, and this consists of studentized deleted residual scores. And so you can see -2, 1, 0, +1, and 2 on the left, and then the predicted value on the bottom. And so on the bottom right chart, we have an assessment here, which has the exam mark and the percentile from the exam. And then at the bottom, we have some parameter estimates that consist of the parameter, the estimate, the standard error, the t-value, and the PR greater than t values. And I won't go through all those, but you can see them displayed there. And our second slide is the 6-2 simple linear regression slide. And so this has the R square and the adjusted R square values. And it also consists of the source, deg freedom, sum of squares, mean square, F value, PR greater than F value, and R square. And this consists of the model, error, and corrected totals. And then in the top right, you can see our parameter and estimate. So intercept and radio, that's 289 and 68. And our regression equation is 289 plus 68, which comes from the radio advertising spent. And if you spend 8,000 on radio advertising, what level of sales would you expect? And so we added those two together and multiplied by 8,000 and got 552,129 in sales. And the radio and the overall model are significant as the p-value is less than the critical value of 0.05 significance. And adjusted R square is 0.3128, so about 30% of the data can be explained by the radio advertising spent. And our last slide, which is the 6-3 multiple regression slide, and we can see the R square and adjusted R square numbers in the top left. We can see the parameter and the estimate values in the top right. And if you do in a regression equation, which is 64, which comes from the radio, plus 4.22, which comes from the TV, plus 3263 comes from the press, and 0.0075, which is the interaction effect between TV and radio, this equals 190. And so the interaction effect is not significant as the p-value is 0.96 and therefore greater than the 0.05 level of significance. The R square increased by approximately 0.33, and the R square change is tested with an F test, which is referred to as the F change. A significant F change means that the variable is added in that step significantly improved the prediction. The F test increased from the base, but not significantly. And with that, that is the last slide, and I hope you guys enjoyed my video.